Hello everyone, welcome back to our stream. Today is Saturday, and I'm gonna spend some time on the core competition. So I think yesterday or the day before yesterday, we finished writing the new interpreter, and the reason why I wanted to write an interpreter is, to set up a proper training environment for our DQN model and potentially other machine learning models, so that we have a solid foundation. So I think we've achieved that. Actually our new interpreter code has already been merged. Yeah, I think the code has already been merged by the Kaggle people, so I think it's pretty good. So hopefully, it would encourage other people to start using TypeScript for writing agents. So I think today's goal is to just, get our training undergoing with this new step interpreter. I think this is gonna, hopefully help us get a better baseline compared to what we are last time. So for the training setup, I have done a training setup before. Sorry, I think the audio is a little bit too loud. Let me just adjust that really quickly. Okay, I think now it should be better. So I actually have done a training setup before for other games, but the other games are not multi-agent, right? So in this game, you have multiple players and multiple agents. So the setup will be a little bit different from the other games, I think. So I'm gonna uh, try to draw out something here to kind of show how I want to structure this, because it's not trivial, right? It's actually not very trivial to set up a multi-agent training. It's gonna be my first time doing this, so I'm gonna draw some diagrams um, to help me understand how I should set this up correctly, right? So we have the DQN agent, and we have a board, and the arrow is the other way around, right? And we also have a training code, right? And we also have other agents. Right, so this is the pieces that we have in our code, right? So I guess the board is not really necessary here. I guess the first thing we do is go from training code to DQN agent. We kind of use the tick function, right? So we use the tick function to get the next movement from our DQN agent. And then we do the same for enemy agent, right? So we do a second tick here. So that will be one round of game, right? And then for training, obviously we need to add to replay memory, right? So we kind of go get an arrow that points to itself, kind of. I think I think it's like that. So that it ticks, and then we need to add to add replay memory. So this is gonna be state, action, reward, new state, and done or not, right? Right, so this is something we want to have, but I think to get the action and reward, we somehow have to, interact with this DQing agent. Obviously, we could have put this into the DQing agent itself, but because the game is being played on the here, right? So the game is actually being played here. So this is gonna be initialize game. So it's actually the game logic is controlling the training code. So we can't do that. So what I'm thinking is, instead of doing that, I introduce a third action here, which is gonna store the action inside the DQN agent, right? And then after that, so after you store the action tick, I think this is gonna be 1.1. After a tick, and then it's gonna do a third thing. Let me just move this up. Oops. Okay. Okay, sure. Whatever. Oops. It's okay. So we have a tick function here, and then stores, and then here we're gonna do a get action, right? We're gonna get the action, the last action from the DQN agent here, right? Oops, it's a little bit weird. Okay, so we're gonna actually get the last action, so this one will become store last action. So we get the last action, and then we are gonna calculate the reward and add the replay memory here, right? So it's gonna be 4.1. Board.next. So this is gonna give us a new state. 4.2 is gonna be calculate reward. All right. And then add to replay memory is gonna be 4.3 here. So the old state, the last action, the reward, the new state, and whether it's done or not, right? Yeah. Yeah, I think this looks like a possible implementation. I think it looks pretty good. So I think this is how I'm gonna implement this, right? So the DQN agent does not need to know about the training process. The training process is always going to be here. It doesn't need to, the DQN agent doesn't need to know about the reward. Right, so we can retain our previous implementation of, act without learn. So this is still going to be there. Let me see here. Okay, I've already done some preparation work here. Right. So this is the old code. I don't think I'm gonna touch that. I'm just gonna use it as a reference when I'm writing the new code. The new code is gonna be here. I have a new train code, which is just a copy of the interpreter. And I'm gonna write my new training logic here. And if it's like very basic, I might submit a PR to the official competition to like kind of set up a baseline, baseline for the TypeScript training. So this is where we're gonna add stuff, right? I think the board tick. Okay, maybe not the board tick. Yeah, so this is gonna be the end thing, right? So this is game ended. All right. So I think what happens here is pretty interesting, because the tick function if I remember correctly, the tick function is gonna actually create a new board, right? No, it doesn't create a new board. I think somewhere it creates a new board. I can't remember where it does that. Okay, it doesn't actually create a new board. It doesn't actually create a new board. Okay, so we need to think about this carefully. Oh, the next actually creates a new board. Yeah, I forgot. The next action that actually creates a new board. So actually here it's gonna create a new board, right? Oh wait, this is not outside the while loop. This is outside the while. So this is the game end, create new board. Step +1, create new board. So we need to think about how to do this correctly. So we have tick and we don't have the store last action. So let's do that first. I think that one is pretty easy. Let me just delete this. I don't think we'll ever need this act handler because it's a multi-agent setup. So it's a little bit hard to do it the other way around. So we need to get the next state after the other agents have acted. So it's to be more accurate. Right, so this we already have the action here. We just need to store it somewhere, right? So I think we can afford to add a new parameter here. I think we can afford to add a new parameter here. This action is the index, right? So we can actually add a new action here. Last action. Just for this particular setup, I think we do need a last action. Right? So constructor wise, this action is gonna be, I think 0 is equal. Okay, it doesn't really know how to do it, but sure. This last action equal to this. Okay, so now we can actually retrieve the last action from at here, right? So the board.next, then we calculate the reward. Actually, before that, we need the previous board, right? So I'm gonna let previous board equal to game board. Right, so this is gonna be the previous board. And then after we add to replay string, and then we're gonna update the previous board, right? So previous board equal to game board. Right. So I think this is correct. And then we need to calculate the reward. So to calculate the reward should be pretty easy, I think. Okay, so this one we already set the current player ID already. So the reward is just gonna be okay. I think let's try something very basic. So let's just try to use the game's original reward. Might be an interesting choice here. We can try using the original rewards to see if it works, right? Yeah, I think that's what I'm gonna try. I'm not gonna bother with our custom reward function. I'm just gonna try using the raw reward to see if that actually works. I think it should actually work to a certain extent, right? Let me think about it. The raw reward is on the scale of thousands, so probably not gonna work very well. because it's on the scale of thousands. And potentially 10,000, right? Yeah. Okay. Okay, so we're gonna do something very simple. We're just gonna divide it by 10,000 or something like that, right? Let's say model maybe final reward or reward equal to do it like this. Total reward divide by 10,000. Yeah. Okay. So this is a very simple, simplistic model that is gonna let it scale between somewhere between 0 to 1, I guess. Yeah. It's gonna scale them uniformly at least. So now we need to add to replay memory. So we're gonna call the DQN agent directly and add it to replay memory. So I have the previous board, the game board, the action. So the DQN agent dot last action, done or not. Okay, so how do we know if the game is not? Okay, so I think inside here the game is not done, right? Okay, actually we don't know yet. Oh, actually we don't know whether it's done or not. So that's a little bit problematic. So we can't actually do it. There will be a off by one problem here. Right, okay. So we're gonna have to move this forward. Okay, let me think about how to do this. Oh, okay, I can just do it like this. Okay. Let's done equal to false. And well, not done. Let's do this. And I'm gonna next cycle. So done is gonna be like that, right? So this bomb tick or tick is gonna return me whether it's end or not. I'll update this and then this should do it nicely, right? Okay, that also means check done. Oh wait, this also updates the reward, right? I think this also updates the reward, so we might have to actually move this up. Might have to actually move this up. Logging stuff. Oh, when do we update reward? Okay, so this is a little bit tricky. How do we do this here? Next. So I don't think we should do it here because it hasn't taken action. We should probably do it here. So this is gonna be this step, right? So this is gonna be step n, and this is gonna be step plus 1. gonna be step n logging step n plus 1, update the reward, and this one, the done is gonna be here. Action, reward, done, and next state. Original state, okay, put it here. Right, so this game board is gonna be the next state, yes, correct. Oh, but the final reward is the reward. Okay, so this is the wrong reward. That's the old reward. That is the old reward. So I might have to move this down a little bit. So we're gonna log the n plus 1 instead of n. Okay, so we're not gonna log the first one, I guess. Yeah, we're not gonna care about the first step, the step 0. We're gonna add this to replay memory. This looks correct. We can add some debugging here, right? And then we can do the training here. Training is gonna be really simple. It's gonna be DQN.training agent. We don't actually need this train count anymore. This is an old thing. I'm just gonna do this. Yeah, so all this would now work correctly. Now that we have the new one. Yeah, I think this should work. This should be a basic setup already. We just need to make sure that everything works, right? So I think we can delete this old one. Don't need anymore. When we add to a replay memory, we could do some debugging here. I think it's gonna be nice if we can do some debugging here. Original state, we can do the current player.core, something like that. Core and ship count, right? Ship count. Oops. Okay, I think that's fine. So we can kind of know if we are doing this correctly. Yeah, I think that's it actually. We can actually start running this to see if it's actually working. We have 10 games here. Let's just run one game. Make sure that we're doing something correctly. Let's see. Reward action, ship count 500. Oh, that doesn't look very correct. Oh, it's keep taking action 0. Okay, so I guess the... Oh no, it's not taking, it's taking action 3. 0, 5, 3, 4, 3, 0. 3. I think action 3 is getting a very high portion. That might just be, you know, how it's doing. But if you take action 2, then it should actually increase. So there's definitely some bug here. There's definitely some bug here. So let's also log the original state's step count so that we'll make sure we're doing the correct thing. Let's run this again. I think it doesn't matter which run we give. State, okay, reward. It doesn't actually build any ships. So let's check. Oops. The build ship is actually action 2. It just takes action 0. Ah, okay. Why this one only takes action 0? Or is it the epsilon thing? Wait, is it the epsilon that is wrong? Okay, that doesn't make sense. Okay, something is not wrong, not right. Okay, let me think where the problem is. Okay, maybe we can log it here. Random action. Let's see whether it's using the random action or not. Oh, wait, what? Huh, wait, that's weird. So it finished the game. Wait, what's happening here? We finish the game and then it start outputting random actions. Okay, so maybe there's a problem with our setup somewhere. The bot tick is being imported here. Agent tick. Okay, let me add a debugging thing here and see what's happening here. Oh, it does go through the tick. It does go to the tick. It does call the tick function. Somehow it's not triggering the random action. Okay, so that's a little bit weird. Let's see here. The move is gonna call get move. And if it's not initialized, we will initialize. Otherwise, we'll do this. Epsilon. This is an async function. Okay, let me add a log here as well. It's probably somewhere else that the setup is wrong. So I'm thinking maybe it's something else, not related to any of these. Let's check. Step. Right, it's going to the step thing. And if it's step, then it's gonna do this. Agent. Episode. Function board. Agent.tick function. So I think we saw that it did went into the this part. Okay, but we didn't lock this, so maybe we need to lock this. Step by step. Right, so we lock this one. And then maybe we lock this one to figure out where it is. It's a little bit weird that we got this kind of weird situation. It's probably something related to async. So it went into this and went into get move TF DQN. It went into this. If it's not initialized, so it is initialized. It is initialized, and then Okay, okay. Okay, maybe we can log some error here. Yeah, maybe there's an error here that is causing it to fail. Yeah, that's most likely the reason. Actually, there's no error here. There's no error here. Okay, so it's emitting every single time. Okay. So it's emitting every single time. Maybe we need to not discard the error thing. Train, no error. I'll just get the error and see what the error says. Somehow my fan will spin when I run this. Definitely some async sync issue here. It's definitely some sync versus async issue here. Is tick function async? Let me check. Yeah, so there's the await here, right? So there's a await here. And this tick is async. So we probably need to add an await here. Yeah, we probably need to add an await here. Let's see. I think this should fix the problem. Yeah, okay. So I think now it fixed the problem. Great. So we don't need this anymore. We can roll back that change here, and then now it should give us the correct output. I think we can also do away with the logging stuff. I think this is no longer necessary. Pretty sure we fixed that. This, and this. Okay, so we just have these three. Let's try the train again. Okay. Okay, let's see how it worked. It's taking random actions. Okay, finally it started building ship after taking 3 for very long. I guess that's just the initial thing, right? Taking 3. Let's see. So I think this is where is the step though? Okay, I think I didn't log the step, but this looks correct. I saw the original and it takes this, and the reward actually dropped because it doesn't take into account of the reward. And the next date is updated correctly, I think. Right, so it takes 2 again, and it takes 2 again, and it takes 0, and it takes 3, which does nothing. 5 also does nothing. I think if you take action 1, okay, it doesn't do anything because what is this? Okay, I guess it sent out the ship here. Okay, send out the ship here. So it got a little bit more core. Right, and now it just dead. Okay. Okay, I think it looks okay. I think it looks okay. It doesn't look wrong. It doesn't look very wrong to me. Yeah, it doesn't look that wrong. So this is setup is probably correct. So I'm gonna do additional logging here. Let me move it here and move this thing here. I don't think I need this logging. I want the old logging. Oops, I think I just deleted the old logging. But it should be fine. It should have my my thing here. Maybe this one. Yeah, I can look at the old one. Where is it? Okay, not this one. This one. Yep. Oh, and we forgot to save, right? So let's just copy the whole thing here. I think we can reuse this probably. put it here. I don't think we need this part. Oh, we still need this part. I think we still need this part. I think this is a separate thing. Save paths. Read file sync. Probably need these files. Oh, the last step, we also need to do it, right? Yeah, we need to do handle the last step, I think, as well. How do I do this? I guess we should write a function to handle this, right? I think it's probably better if we have a function to handle this. Record string log. A Yeah, I think we probably need to do this here. And we're just gonna put everything here. How do we get the reward? I guess reward has to be different. previous board. Action. Reward. Done. Board game. Board. Okay. Previous board. Action. Reward. Next state. Index episode index. Okay. Okay, I guess we can take the index here. The reason why I'm doing this is because I need to reuse this logic here. Right. So that's inside and this is outside. So it's kind of still have to do this here. Right, so we don't need this anymore. I can't use await to make this a thing. Which means I have to add await here. Early win equal to 1 and okay. Okay. How do we know if we won? Okay, I think we have the done here. Oh wait, we don't need the outside one actually. Yeah, I just realized actually I don't need the outside one. Because by here it's already done and we already calculated the reward, right? So we don't actually need this. Yeah, we don't actually need this. Yeah, but still good to have this outside, I guess. So the one logic is gonna be pretty simple. Okay, we can add a 1 here. Oh, do we need wings plus plus? Oh wait, we have it here. Okay. Okay. So we kind of have two different winning things here going on. I guess we can just use this, right? Yeah, I think we can just use this. Like, there's no reason to do this twice, I think. Okay. If this and turns smaller than 400, I think the step is gonna be 399, right? So probably need to change this to, wait a second. Okay, we didn't actually last until 399. We can figure this out later, I think. Let me see. Actually, let's think about this, whether it's 399 or 400. So here we do the next. I guess it depends on how we code this. If it's greater or equal to 399, then it will return true already. So it's the largest is 399. So this should actually be 399, not 400, I think. Don't need this anymore. Final reward. It's just gonna be reward. Turn. Okay, so the turn is gonna be useful because we can log this here. Completed episodes. Okay, this is just gonna be. Wait, where does this come from? Okay. Okay, I think this is fine. Just gonna change this quickly. Turns. I think we can afford to define the turns here. Otherwise, I don't want to keep defining this over and over again. So this is gonna be here and used here. Okay, this one automatically fixed itself. I need to define the summary writer. So it's gonna be about here. I don't have TF here, so I'm gonna import the TF here. Actually, this should be up there. Okay, so looking good. I think looks correct to me. No, it looks correct to me. So these are the. So this is the end of the turn thing. Do we actually need the in between the turn thing? No, let's do something simple first here. Okay, I guess we can borrow this thing. We can borrow this thing here. Obviously, we don't have this anymore. Now we have to get that back from somewhere. How do we get the ship count? That will be ship string. Okay, let's just copy this here, and then we'll figure out how to get this from somewhere, I guess. Okay. Maybe the pet function was also different. Let's see. So we need ship count, inside ship count, and shipyard count. I think this should do it. Okay, so instead of current board, we have next state. Oh, we don't have shipyard count. Okay. Then, okay, so we have the ship string here. It's between core and action, so let's retain that. And we got the reward here. It's simple reward, nothing fancy. I think that will do for now. And then I'm just gonna do done, or like not right. Oh, we need a save string, I guess. Oh wait, the save string is a different thing. Yeah, the save string is actually different. Okay. Oh wait, I think I made a mistake. I think I made a mistake. This is supposed to be outside, not inside. Okay. Okay. I think I made a mistake here. So there should be another function called endgame log. Yeah, I think I made a mistake here. So it should be here. Okay, I guess we can still take in the next state. Let's just put everything here. We don't need this. Save string. Alright, because the save string now is moved to per turn, so we have to put the save string here, right? And then I'm gonna move this to here. Yeah, it's a little bit different from how I used to do this. So this is gonna be our end of the game log, right? So it's gonna call this. I guess we don't need this. Okay, so we're gonna do it here. Do we actually need this? Maybe we can do like a simple one like this, and then game log. It's gonna be index reward. Main index reward. The next state is gonna be why do we even need the next state? Ah, turns. Okay, so we could just pass the turns here. Okay. So the number of turns is gonna be game board.step, and the one is still gonna be the one. I think we can do it like this. Yeah, it should be correct. Should be correct now. Oh wait, why do we have another wing here? We can delete this later. So let's try this. Reward is 0. We already won against the miner. That's interesting. We actually won against the miner. Oh wow, that's interesting. Let's see. The reward is 0, which is definitely something wrong. It should not be 0. Let's see what's happening here. Because it's to fix 0, I guess. That's why it's 0. Yeah, probably because it's to fixed 0. All right, let's change this to 4. Yeah, so now it has some kind of reward. Now I wonder if I train again, it would increase in the T. I think it should increase T to reuse the previous model. So let's see if it does that. It should start with 410. Wait, what's happening here? Oh, it just exited. Okay, something is wrong. That means something is wrong here. Wait a second. Uh-huh. Okay. I guess I have to again do the debugging. Canary property now of trainable. So target network is not initialized. Oh yeah, so okay, so how can we initialize target network as well? Wait, where are we loading? We need to figure out where are we loading the model, right? It's definitely being loaded here because the training code doesn't actually have initnet or anything like that. I think it doesn't have any logic to initialize it. It doesn't have any logic, so the logic must be here. Copy weight. Train agent. Load model success. Await load model. Init equal to true. Okay. I guess this is where I need to make the change here. Because previously I was initializing it here. So it's kind of have to do like this. I guess I should call this dot init first. So that we at least have that. Oh, yeah. So I think we should definitely do a init net here. And then we can do the copy weight thing here. Yeah, I think that would make sense. Okay, load successfully. All right, so it loads successfully about 900. Now if I play it again, it should be yeah, it's increased. Wait, why is it 1.9? Shouldn't be that high. Should be about 400. Increased by 400. Doesn't look correct. Okay. So the T number is not going up correctly, I think. Let me try to run it on a fresh one to see what's exactly wrong. So the T number is not going up correctly. Seven, 9, 7, 9, 8. We're going up twice as fast. Going up twice as fast. Act without learn is getting the frame count. Oh, okay. So this one is already giving the frame count. Okay, so this is an interesting thing. I think it shouldn't. Yeah, I think I will just do it here instead of doing it there. Yeah, I think doing it here is better, it's cleaner. I like this more. Let's try again. Now it should work. Okay, 399 looks good. Let's make this 2 episodes and run it again to see if it's working. So it should be about 3 times 4, about 1000 steps after this training, and the loss and kill should be none because we haven't started training. We only start training after we fill up the replay memory. Right, so it's about right. Yeah, it's about correct. So I think now it's the time to put it into actual training. So this is gonna be our first actual run, right? 2, 3, 5. So this is gonna hopefully start training something. The reward function is completely garbage, but it should at least produce some kind of graph, I think. Let's also run the TF board thingy. Okay, I need to do the EMV thing again. So it'll be like this one. Oh no, I think I don't have. It's probably this one. Oh no, not this one. No. Okay, it doesn't. I think this one is correct. So I just need to replace this. Yeah, okay. And we got this. Let me just put a couple block here, and we're gonna take a look at this. Turn reward, loss, Q predict, Q target result turns. Okay. Can maybe get this as well. Result turns, stuff like that. Okay. There's nothing here, which is a little bit suspicious. Oh yeah, because it hasn't started training, right? I guess that's why. It's saved. Done. Okay, I can see some variation in terms of shipyard, so it's definitely doing something. Not sure what it's trying to do, but it's at least acting. It hasn't even come to the training part, so that means our simulation is actually very slow. Like we haven't even started training and it's already very slow. So this is not a very good sign actually. It's much slower than the Python simulation. Yeah, that's not a very good sign. That means the training using this step simulation is gonna be much slower. It takes about 3 seconds to complete 100 games. That's really slow. I have to profile this to figure out why it's slow. Otherwise, it's not gonna work. Memory is fine. CPU is interesting. Holy shit, this is actually very slow. I'm just gonna let it fill up the replay memory and see how the graph is looking like before I make the next move. I probably need to do some performance optimization on the simulation. Otherwise, it's gonna take ages to like train it. Oh my god. No, it's not even training. Yeah. No, it's just like playing the games. It hasn't even started training. It's already very slow. Imagine it's 4-player, it's gonna be even slower. I'm not sure why it's taking so long though. I guess it's just cloning the board takes very long, something like that, I think. I mean, it's not that slow, but it's still much, much slower than the Python one that we used before. The Python one, I think takes about 4 seconds to complete the whole game. And here is like 3 seconds to complete 100 games, which is gonna be 12 seconds. It's like 3 times slower, right? So that's very slow. Get something to drink. It's actually winning some games, surprisingly, before we even start training. It's already winning some games. Oh my god, it's actually doing better than the previous spot. And it's a little bit strange, right? How can it be winning games before we even start training? I find it very hard to believe. Okay, now it's actually training, right? Because you can see it's like very slow now. It's very, very slow now. So yeah, now it's actually doing training, right? Yeah, for sure this is doing training now. I'm surprised that it's it was like winning games even before we start training. That's really surprising. That is very surprising. Okay, now it's taking really, really, really long to complete 100 games. Uh, this graph is really, really interesting, right? Like we can even compare it against our previous baseline, which is, oh wait, where's our baselines? It's all gone. Where are our baselines? Wait, I remember I had a baseline before. I think this one. Baseline 2, okay, so the baseline was 201. Oh, it's unfortunate that it's the same color, so gonna have to change the color of the baseline to green. Like, this is really strange. It could be that our new interpreter is not giving us the correct results, right? It's not really the same behavior as the Python one. That's why it's winning so much against the miner. Yeah, it could be that. Or it could be that this training method is much better. Holy shit, this is very, very slow. Oh, we're winning games, like we won 2 games in a row, which is really surprising. And the loss is actually very, very low. How are we encoding the state actually? Quite curious. Oh, we didn't have the TF model thing. Okay. Didn't have the TF model thing. I guess we should add the TF model thing somewhere. Mm. Yeah, I'll think about how to do it because now the setup is a little bit different, so it's a little bit tricky to do this because you can't print to the standard out directly. Log initial model information if index is equal to 0 and I is, there's no I here, and I guess step. We can print a summary here, right? I think this should be fine. Should be fine. Okay. Is the graph? Oh wait, that's not the correct graph. I'm looking at the wrong graph. It's a little bit too early to tell whether this is correct. And also in general, it's really slow. It's really slow in general. Not too sure if it's actually training anything. It's kind of weird. I was expecting this to be much better than a Python one, but turns out it's much, much slower. Maybe you do need to write some C++ code to do the simulation. Yeah, I think probably writing Node.js to simulate is not the best idea. I think the guy who wrote the board class also didn't consider like performance, didn't treat performance as a high priority. That's why it's not very performant. Or maybe I'm doing something wrong. I don't know. Definitely need to optimize the performance here. It's way too slow. Okay, now it's starting to lose some games, which is okay. I think it's expected to lose games at this stage. Mhm. Oh, also, it's saving the model in every single turn, which is kind of expensive thing. Oh, 18 megabytes of weight. That's quite a lot. I definitely need to do some stuff here. Yeah, the save thing should not be outside, should not be inside. That's the first thing I need to fix. I don't think you're supposed to save it inside. And then I'm also gonna make the make it train like only at four. So it's only gonna train for every 4 frames instead of training on every frame. That should hopefully make it slightly faster. I'm just gonna collect a few more data points from this run and then make those changes. I think actually I can make them. I'm not too sure if it's gonna interfere. I think it's gonna somehow interfere with it. So I'm gonna let it finish this last run. Yeah, there's a few other things I need to do before we can train this properly, right? One is to optimize performance. The other one is maybe get back our old reward function, right? So those are quite necessary. I'm not sure where the bottleneck is right now, so we need to do some performance thingy. Okay, now you can update, I guess. Yeah, it's really weird that it's able to go to win games. Yeah, this graph doesn't really show much, right? So let's do this. So the first thing is to move this out. Okay, actually this doesn't have to be, we don't need to wait for this, right? I guess it's fine to make this like not await. Should be fine to not make this await. Oh, but it might mess up this thing again. Maybe we can get rid of this thing. Yeah, I don't think that's necessary. Save string. So I don't have this anymore. I'm gonna put the save string here. Okay, so this is gonna save after each game. Hopefully that's gonna make it speed up the thing process, right? So they doesn't get bottlenecked by IO at least. Then the other thing is to train every 4 steps, right? So I think that's also pretty easy to do here. So it has this sync every frame. Okay, sorry, not that. I think it's this thing. Session. This training frame interval equal to 1. Yeah, I think this is correct. The training frame interval is we're gonna uncomment this to make it 4. Right. So I think we can add some debugging stuff here. So how do we know that this actually works? Okay, I think this is fine. It is fine. It's gonna print out a lot of things, I think, but it's fine. I think it should be fine. Let's see. Now it should be much faster. Okay. Oh, actually, it's in fact much faster. Oh, I think just now there was bottleneck by IO. So actually, I take it back. Maybe the simulation is not that slow. Just now it was actually bottlenecked by the saving model thing on the IO side. So that's the good news, I guess. Okay. So it's just the IO bottleneck. Okay, good. So it doesn't actually have that problem. Let me check. Okay, now I can see the skip training. Let me check. Yeah, it's definitely skipping trainings. Okay, so it's working. Right. So I can just remove this, I guess. Don't actually need that. So now I'm gonna do a proper one. My God, so many useless things here. I'm gonna do a cleanup later. But for now, yeah, now it's much faster. Wow, it's yeah, just now it's just IO bottleneck. Okay. I was wrong. I was completely wrong. So this is actually faster than a Python simulator. Looks like it's much faster than Python simulator. Without the bottleneck. Okay, so this is pretty good. This is pretty good. I guess I don't need to do optimization anymore. That's pretty good. Interesting stuff. Somehow we're winning a lot of games even though it's completely random. It's a little bit surprising. There might be some bug somewhere in the code. Yeah, now it's slowing down, but it's still pretty fast. Yeah, it's still like pretty okay speed wise. It's pretty okay. So I think we can actually start to observe this properly, like let it train for a longer period of time and see if it's actually doing something correctly, right? I think I'm just gonna manually observe it for a few more minutes and make sure that it's actually doing the correct thing. Then I'm just gonna let it continue training for like maybe 1 hour or 2 hours and see how it goes, right? So it's definitely much faster than the previous one if we were to compare. uh, yeah, it's just 1 minute, right? It's much faster compared to just now the one that was probably bottlenecked by the IO. Let me just make sure that this is still outputting the model. 541. Okay, correct. Oh, also let me check the model summary. It doesn't have model summary. Okay, so we have to fix that model summary thing. It doesn't actually output the model summary here. Okay, sure. Mm-hmm. Yeah, I would imagine this raw reward is not very good, right? I think I tried this with previously with the old setup. It didn't really work very well. The raw reward. Maybe it will work well if you give it long enough time, but for me it didn't really work last time I tried it. So I'm quite interested in seeing whether it will work in this new setup. Okay, doesn't like now it's just losing all the games because it's losing its shipyard really quickly, right? Yeah, it's losing shipyards pretty fast, but the queue is still increasing, so that's a good thing. So if you look at the current trend, the queue is going up and the loss is stabilizing. I think it's normal to kind of go up a little bit at the beginning while your queue is jumping up really quickly. So this is to be expected. The result is not looking very good, but I think it's also to be expected. Yeah. So let's go to our to-do list here. So we actually have run 273, which is the new interpreter training setup. So I think the next step is to like proper reward. So we haven't ported back our old reward system, so we need to do the proper reward, and then we'll just take it there, right? I think this setup should be more or less correct. Hopefully. So far looking good. So far it's looking good. You can see the Q value still going up. And the loss is not going up that much. So it's kind of stable. It should start going down pretty soon. Oh, this one we actually won, right? I think. Oh, we actually probably maybe we didn't win. This not too sure whether we won this one or not. This one we probably won. Yeah, we won. Started winning some games. Okay, interesting. Maybe this one is gonna just outperform our previous baselines. Who knows? Could be possible. I don't think the raw reward is a very good reward system because it's like kind of encouraging you to like collect core instead of building ships. I don't think it's a particularly good reward. At least given a short training period. If you train it like for very long, like or for a few days or a few months, the AI might be able to figure out. But I don't think it's able to figure out in a short period of time that it needs to build ship and shipyards to like actually win this kind of games. Alright, I think the graph is looking pretty okay for now. Yeah, I think the graph is looking pretty okay. I might just let it continue running and then we'll come back to check whether it's still doing okay after like maybe 15 minutes or 20 minutes, right? All right, I'll leave this continue running and I'll see you guys in 15 minutes. Hello, hello. All right, we're back. So let's take a look how it's doing. Looks like we have a drop in performance, but that is still normal, right, at this early stage. And we got a very nice graph for Q. I think this is the perfect looking graph for Q. It's supposed to go up and somewhat stabilize afterwards. On the other hand, the loss graph is looking a little bit suspicious. It's supposed to go down after the initial jump, but it's not going down yet. So maybe we need more time. I'm not too sure. Oh, actually looking at the result, it's actually going up a little bit towards the end. We haven't actually won early games. I guess that's just because of the reward, how we set up the reward. The reward is now currently only counting on the core, so it's not actually valuing ships or shipyards. That's why I don't think we're gonna be able to eliminate the enemy before the turns run out, right? I think so far it's looking pretty solid. If you take a look at the number of cores we have at the end of the game, it's actually not too bad, not too bad at all. It's just not learning to build ship or shipyards, right? Which is to be expected given how we model the reward. As you can see, this one, I think we actually won this, so it's pretty good. It's doing pretty good given a very simplistic setup for the reward. So I think the next step would be do a proper reward. Also, I want to do a model summary. I think model summary is not being done for some reason, even though I added the logic. So not too sure what's happening here. It's supposed to print out a model summary here, but it didn't. Let me check here. Okay, here also doesn't. So probably something is wrong here. Right. All right, I think it's going pretty well. I think we managed to achieve what we set out to do in this stream. So we managed to set up the proper DQN training with the new step interpreter, and the performance is pretty good in terms of how fast it runs. It's actually exceeded my expectation. It's actually faster than Python, and it's definitely gonna give us more fine control over how we want to train this, and we're not limited to like we don't have any weird constraints anymore, so we can like unleash the full potential of TensorFlow here, and potentially we could move much faster with the DQN model and also other machine learning models in the future. So I'm interested to try I think the other one, which is pretty popular for Kaggle competition, is A2C model. So it's gonna be the I'm not too sure. Yeah, advantage actor critic, right? So something like this. I think this is pretty popular, so I'm gonna try this. And the other one is definitely PPO. Yeah. So PPO and A2C are some two other things I want to try out. But that's gonna be after we've done all these things, right? So I think I put them somewhere here, right? So these are the new things. Actually, we completed the new step interpreter, so we can take that off, right? Yeah, it's pretty good. So I think that's gonna be everything I want to do for this particular stream, and I think I'll probably come back later today to do another stream for tuning the reward function and also getting our model summary printed correctly. So that's what I think I'm gonna do another stream later today to do those things, and hopefully we'll get some decent result by then. But until then, I will just keep on training this one and see what we get. Like maybe after 1 million rounds, right? It's going pretty. It's doing pretty fast actually. So I think we'll get to 1 million rounds pretty soon, right? So you can see particularly here the reward per turn is actually going up. So there's probably it's a positive sign, right? It's doing something useful here. All right, I think that's